like we said, I want to talk about Charles Law now. Charles Law is a law that is talking about the volume and the temperature. The volume and the temperature. The volume and the temperature of a gas. So the law states that the volume of a fixed mass of gas is directly proportional to the temperature, provided that the pressure remains constant. The volume of a gas is directly proportional to the temperature, provided that the pressure remains constant. Alright, so since V is directly proportional to T, that means there is a constant before T. When that constant comes, to find that constant, there is a volume and there must be a temperature. There must be a volume and there's a temperature. So if the volume is 1, the temperature is 1, that means V1 T1, V2 T2. Now in a gas that we subjected to experiment, I want to check the temperature. Maybe the temperature as it was before is not the temperature we are using now, but the pressure changed. I want to know the temperature. We know the pressure, but we don't know the temperature. Let us see how we can find it. Okay, there is a question here. A certain gas of mass 300 cm at 35 degrees centigrade occupy a vessel. Calculate the temperature if the volume is reduced to half. Wow, the volume is reduced to half. That means half of 300 is 150. Now, first thing first, we need to put down our parameters. The first volume is 300. Now, we have temperature 1 and temperature 2. Temperature, as it stands here, that we know is measured in Kelvin. It's not in degrees Celsius. Even though the question comes in degrees Celsius, we need to change it to Kelvin. From centigrade to Kelvin is just to add plus 72, 73. From centigrade to Kelvin, what you need to add is any number you have in centigrade, you add it plus 273, and anything you have there is in Kelvin. Hope you are following. Okay, so I have 31 degrees Celsius here, or centigrade. We convert it to Kelvin, that means 31 plus 273, which will give us 308. We have talked about the conversion of this temperature in our physics class, but I want to make it experience here so that you will still understand. Okay, so the volume that they gave us in they told that the volume is reduced to half. So half of 300 is 150, and we are asked to find our second temperature. So what do? We put down our formula. V1 over T2 equals to V2 over T2, which will give us 300 over 308 times 150 all over T2. We cross multiply, making T2 the subject of the formula, will give us T2 equals to 150 times 308 all over 300. If we check, we have V1 T2, V2 T2 as the solution of this question. Alright, this is the formula, and when we impute these parameters into this formula, we will know that V1 is 300 while T2 is 308. V2 is 150 while T2 is the unknown. So we cross multiply, making T2 the subject of the formula. When we do that, we have 150 times 308 all over 300, which will give us 154 Kelvin. The answer is left in Kelvin. Okay, now they may ask us V2 or T2. Now it's left for us to cross multiply, making 1 the subject of the formula. Making 1 the subject of the formula. By the way, it is not, the question is not limited to this. We need to push further. Look for more questions. But I know that the arrangement is not far-fetched within this arrangement. I choose this one because I know that this will work. This is one of the one that looks, every other one is straight. This one looks contradictory. I just picked it so that we can use it as an example for this class. Okay, just go make some research, and you will get done with this Charles law. The next point we are going for is general gas equation. Now, before I go into general gas equation, I would like to make a clarification. Okay, now Boyle's law and Charles law were joined together to produce general gas equation. These two laws were put together to produce general gas equation. If you check the Boyle's law, we have PV, and we have this, we have V over T. Now, P and V are the same thing. V and T are for Charles law. Now, V is appearing in the two. So what we do, we have to use one T. We have to use one V. That will give us PV over T. And this is the law for gas equation. This is the formula for gas equation. Alright, let us go to general gas equation. Talking about general gas equation. Like I made mention earlier, I told you that there is no hidden fact in general gas equation. It's just a combination of gas law and Boyle's law. So what we do is we combine Boyle's law and Charles law, and it gives us the equation. So, but note that there is what we call standard temperature and pressure, and we most of the times we use them in asking questions for this particular section. Now, that standard temperature and pressure means for a standard environment. For a standard environment, the standard temperature is 0 degrees Celsius, which is the same thing at 273 Kelvin. The standard temperature is 1 atmospheric pressure, which is 1 atm pressure. 1 atm pressure is the same thing as 760 mm mercury. It is also the same thing as 1.01 times 10 raised to power minus 5 Newton meter square. So these parameters represent the standard temperature and pressure. Standard temperature for 273 Kelvin, standard pressure for 1 atm or 760 mm mercury, or 1.01 times 10 raised to power 5 Newton per meter square. Okay, let's go directly to the question, because there is no law. There is no law for this equation. It's just a combination of gas and Charles. Boyle's and Charles. Alright. Okay, let's look at this question that says the volume of a gas is 300 centimeter cube at 27 degrees Celsius and 700 millimeter mercury. Calculate the volume at 36 degrees Celsius and 750 millimeter mercury. Now they gave you the volume and the temperature and the pressure. But at this point, they ask you to calculate the volume while you have your temperature and your pressure. Like I told you, we convert the temperature to Kelvin. That means 27 degrees Celsius, which is converted to plus 273, give us 300. 36 degrees Celsius, we add plus 273, give us 309. Now, our P1 is 700, P2 is 750, V1 is 300, and V2 is what we are looking for. What now we do to make sure that we get what we want is to impute it in our formula, which is P1 V1 over T1 equals to P2 V2 over T2. Equals multiply to make V2 the subject of the formula. I will have P1 V1 T2 all over P2 T1. Remember, you cross multiply and make V2 the subject of the formula. Okay, now what happens there is we substitute every figure there into the formula. P1 700, V1 300 times T2 309 all over P2, which is 750, times T1, which is 300. If you press your calculator, you will see 285 centimeter cube. Something close to it or the same, depending on the calculator you are using. Okay, now there is diverse ways they can put these questions. There are diverse ways they can put the question. They can and pressure. They may write at STP. Calculate the volume at STP. Now what you need to do is to put your pressure and use your pressure and use your temperature. They may give you the STP and give you the ones you're looking for here, depending on how they want to put it, rearrange it. Okay, that's by the way. But what I believe is the question does not fall above find P2, find V2, or find T2. You must find one of them. Hope you are following. It's just simple. Cross multiply, make the unknown the subject of the formula, and you have your answer. Okay, that's just it. The next thing we are going to talk about is ideal gas equation. But before I go to ideal gas equation, I like to tip a little thing there. Alright, every standard gas must have pressure, volume, and temperature for it to be standard. But for you to be an ideal gas, you must have number of moles. You must have a number of moles. This thing can be any kind of gas, but the gas is ideal. That means it has number of moles. For an element to exist, that element must have its number of moles. 1 mole of oxygen, 2 moles of sodium, 3 moles of iron, depending on how it is. So for a gas to be ideal, it needs to have number of moles. Okay, let's go to ideal gas equation so that I will throw more light to what I'm saying.